Okay, welcome everyone. This is Joe Armstrong and the Power Systems Virtual User Group webinar. And first of all, I just want to thank you all for joining. Hope everybody is safe and doing well as we continue through our pandemic crisis, which seems like things are opening up a bit more, and maybe businesses are ramping up a bit. I know that for us IBMers, we're still all working from home, as I think a lot of people are still. So I hope you're all doing well, and we'll get going with today. I am recording this session, and so I need to let you know that. And today's topic, we're just going to jump into it, is single root I/O virtualization, or otherwise known as SR-IOV. And the presentation materials are out on the wiki. I'll probably throw out a link to the wiki if you don't already have it, but it's in the invite and everything that I send you. But the presentation materials are out there. There's actually two files. So we've got two speakers today. One is Chuck Graham. Chuck's going to start us out. And let me get a little thing up here. Chuck's a senior engineer, or a senior technical staff member with IBM. He's the lead architect for PowerVM SR-IOV technology, and spent most of his career as a developer and architect for physical and virtual I/O solutions. Works in the Power Hypervisor area, and Chuck is also a master inventor, has numerous patents in the I/O and other related fields. So having worked in development in the I/O and hypervisor type area myself, that's kind of a cool place to be. And so we welcome Chuck. Chuck's going to start us out. When Chuck's done, then we're going to have James Chandler is going to join us. James is with Lab Services and has been with IBM helping customers for many, many years do things right. James is going to talk to us a little bit more about a tool that can be used from Lab Services, in addition with Lab Services, a tool that can be used to help migrate from VIOS to SR-IOV. There's some tricks to that, so we're going to talk about those a little bit. And James is going to tell us about this tool and a little bit about Lab Services' ability to help you with that. So two things there, okay? So we're going to start out with Chuck. And like I said, the presentation materials are on the wiki. When this is all over and I get the recording done, I'll post a link to the replay on the wiki as well. Okay, so with that, Chuck, I'll pass it over to you.
Okay, thanks, Joe, and thanks for the opportunity to talk to the group here. We made a presentation, it's probably 3-4 years ago now, on SR-IOV. So it's nice to get back, give you a little bit of an update, although I will kind of cover some of the same kinds of things such that give you the background behind some of these things because they sort of build on each other. So I'll run through some of the basic architectures, again, just as background, and then we'll talk about some of the newer solutions and capabilities that we have. Let me page forward. So, excuse me, a little bit on terminology, because we'll use this as we talk through the presentation, but when we talk about dedicated adapters, those adapters are assigned to a partition and owned by that partition. That is by far, your best performance because it's completely owned by the partition, and the partition has direct access to it. That was the initial adapter technology that was available when we first came out with Power Systems, and prior to Power Systems, we had then came along with a virtual Ethernet capability that was allowing communication between partitions, going through a hypervisor switch to expedite the communication there, but it didn't have initially a way out. We do the bridging through the shared Ethernet adapter. So most people are familiar with these technologies, and some are now familiar with SR-IOV and some of its derivatives that we've come up with. So the question is, so why did we need something new? And what we've seen, and this is continuing to evolve, but with 10 gigabit Ethernet and going beyond 10 gigabit, we need something that's a little more efficient, or a lot more efficient in some cases, as we look at 100 gigabit and 200 gigabit, and that provides less overhead and can provide better performance in a shared kind of environment. So we initially have two technologies, and I'll talk about a third that just recently became available in the production environment. One is single root IO virtualization. This is an industry-developed capability. There's a PCI SIG specification that covers how adapter vendors produce SR-IOV capable PCI devices, and that's what we leverage for SR-IOV and some of these follow-on capabilities. I'll talk a little bit more where that comes into play. In addition to that, IBM has developed something called VNIC, it's Virtual Network Interface Controller. It's a new virtual adapter type. So if you're familiar with virtual Ethernet as a virtual adapter type, this is a new one called VNIC. And I'll go through the details of how it's used. And again, the intent here is to provide a more efficient, better performance out of the box kind of shared adapter capability that allows a lower cost by reducing switch ports and those kinds of things in the data center. So we started this journey back in 2014, and I'm not going to crawl through this, but I just wanted to give you a view that this has been a journey where we've continued to provide feature function on a regular cadence over the years, including up to last year and even this year. So I'm going to quickly go through this SR-IOV architecture chart. If you've seen anything on SR-IOV, either at tech use or presentations I've done previously, this will look familiar. But I thought it's good to go through this just as a base for everybody to have a common understanding for those who may not be familiar. So we have these SR-IOV capable adapters, and SR-IOV capable adapters have what they call virtual functions. And virtual functions are the slice of a physical port that can be individually assigned to a partition. There are a certain number of virtual functions per physical port, and it varies depending upon the adapter the SR-IOV capable adapter and the adapter and the port type. This particular adapter is one of our first adapters that we came out with that had two 10 gig ports and two 1 gig ports. And so, there were 20 virtual functions for the 10 gig and 4 for the 1 gig. Now, what you see here in the partitions are logical ports, and we configure a partition. You can create a logical port as a network interface from the HMC, from the management console. And what happens then when that partition is activated, or you can dynamically add logical ports to the partition, when that happens, then it gets connected directly up to a virtual function on the adapter. So that is direct access from the partition to the adapter hardware to that particular slice of the adapter that logical port can interface directly to. This looks like physical I/O from the adapter perspective. That will be important when we talk about VNIC and some of the other technologies to understand. This looks like physical I/O, so you get that direct access to the adapter. One of the things about SR-IOV is that there is internal switching at a physical port boundary. And so what you can see here is that when I've got two logical ports that are on the same physical port, it can actually communicate directly without it going out the physical port. Now, this is the default mode that a physical port will come in, be configured in when you first bring an adapter into SR-IOV shared mode. But there is also a mode which forces all traffic out the physical port requires a switch that has something called hairpin turn that will route things back in. But if you have an environment where you need all your traffic to go out into the network because you've got firewall or intrusion protection and those kinds of things, there is another mode. It's called Virtual Port Aggregator, or VEPA, that you can set that forces everything out the physical port. So this just to demonstrate quickly that, you know, I can, one, have multiple logical ports and partitions. The limit is really, you know, what makes sense from how many network interfaces you have. So, you know, generally it's a limited number, but you can have multiple. The other part here is that you'll see is that traffic, when they are on separate physical ports, will go out the physical port and have to come back in a different physical port. Now, in this case, the switch isn't required to have this hairpin turn capability. This is just normal network traffic. But again, so different ports, it goes through the network, same port, it can go internal. So one of the other things I wanted to point out here on this chart is that for those of you who have shared Ethernet adapters and virtually Ethernet interfaces in your partitions, you know, using the traditional bridging that existed for many, many years, one of the things you can do is assign a logical port to the virtual I/O server and have that be your physical device for a shared Ethernet adapter. And that's important for two things. One is some of the adapters, you know, there are a limited number of virtual functions, some of them less than others. And if you need additional fan out, this is one way to do that. If you have partitions that have network connectivity requirements, but don't necessarily have, you know, low latency, high speed requirements, you know, this is a way to get additional fan out. But the other thing that we've talked to a number of customers about that you know, to help them understand is this is a path that if you're comfortable with your current shared Ethernet environment, it works well for you, you don't have any additional performance requirements, it's good to think about that, you know, even if you've got that kind of environment, and if you think that in the future you may want to go to, you know, SR-IOV, VNIC, or one of the other, you know, higher performance, lower overhead kind of environments in the future, one of the things to think about is that you can, you know, as you're standing up new systems, if you get the SR-IOV capable adapters and you put them in SR-IOV shared mode right out of the get-go, you can assign that logical port, maintain that same shared Ethernet, you know, virtualized network environment as you have today, but still have the capability in the future when, you know, maybe you've got new workloads that have more demand, you know, or there are new things that you want to do that require additional capability. Maybe you don't get through virtual Ethernet, and I'll talk about some of the quality of service kind of things you can get. But you can start out with the, you know, your sort of your traditional environment, but now that you've got that adapter in shared mode, that adapter can be shared by other partitions, and even the ports can be shared by other partitions under most circumstances. So you can start out with your, you know, current existing shared Ethernet environment, using an SR-IOV adapter in shared mode, and then evolve it and grow it as it makes sense from your particular solution perspective. So I'm just going to, I had mentioned the, yeah.
One thing, I know you're going to get to this load balancing thing, but there was a question on, you know, you have virtual Ethernet ports and logical ports up there. Somebody asked the difference between the two. You want to just maybe mention how they're created, or what the difference is there, other than that the logical ports go directly and the virtual Ethernet connect into the SEA?
Yeah, so that's a good question. So the virtual Ethernet, so what you see in partition C there on the far right, this connects into a hypervisor virtual switch. So it's purely a software interface, right? Software and firmware interface, and communication between partitions is done through that hypervisor switch. So data is actually copied by the hypervisor from one partition to the other partition. And in this case, if you're bridging through your VIOS through SEA, the packets are going to be copied into the virtual I/O server and then get bridged through the SEA out to some physical device. And in this particular example, we show that physical device as a logical port. So you have that overhead associated with the moving of the data through from one partition through the virtual I/O server, setting it up as a normal set of network traffic on that logical port or physical device, and eventually flowing out to the adapter to go out on the network. A logical port is more like a physical device driver. In fact, it is a physical device driver. So if you had a physical adapter and that was owned by a partition, we talked about the dedicated mode or dedicated adapters. That device driver in that partition, say partition A, that far left partition and far left logical port, you're talking directly to that hardware. You're talking to a virtual function on that adapter. So you're setting up to do packet transmits and packet receives right into the hardware itself. That looks like physical hardware. So that's the main difference. So that's the logical port's a hardware device driver. The virtual Ethernet is a software device driver. Software firmware device driver. Did that help?
Yeah, that did. That was great. Thank you.
Okay. The last thing I want to point out here, and I'm going to go into more detail on this later, is that with the logical ports, you have the capability to, we call it a capacity value because it really can cover more than just bandwidth. But one of the key things that when you set this capacity value, that's sort of a percent of the physical port, it dictates what the desired minimum bandwidth is for that particular logical port. And I'll go into more detail, but it really is a minimum bandwidth. So, it sort of tries to ensure that, that logical port, if it has demand for that minimum, that it will get that minimum bandwidth. If it doesn't, that doesn't have that demand for that minimum, that bandwidth is available for other logical ports, and we'll see VNICs and other things in the future in other charts that will also share these adapters. But that excess bandwidth that the logical port isn't using is available for other logical ports that may have demand beyond their minimum capability. So it really is a minimum, and it's a desired minimum. Okay, I'm going to flip through the next couple charts. I've got several of these requirement charts in here. I put them in here just for reference. I'm not going to go through the details here, but they are in here if as you're starting to think about SR-IOV and wanting to know what the OS requirements or firmware requirements or HMC requirements are. You can use this for reference. Initially, there was P8. We had P7 support. I didn't put any of that in since we don't really support Power 7 anymore. But so there's PA requirements. There's the initial P9 scale out server requirements. So the 922s, 924s kind of class. And then when we initially came out with the E950, there was a set of requirements that was shortly we came out with a 980 and a release with the 950, so there were some updated requirements there. So really, if you're looking at anything recent, this is for SR-IOV, and we'll have similar kinds of things for VNIC and VNIC Failover. But for SR-IOV, these are the requirements you want to look at. Okay, I'm going to spend a minute on VNIC, and then we'll get into VNIC Failover, but I just wanted to give the background of VNIC. VNIC is another virtual adapter type. We talked about virtual Ethernet as a virtual adapter type. VNIC is another a newer virtual adapter type. And you see how that plays similar to what we saw for virtual Ethernet. The intent of VNIC is to really leverage this SR-IOV capability, this internal switching capability, and to leverage the QoS capability to provide better performance in a shared adapter environment. So this is just kind of the high-level architecture, the base architecture. And when you configure a VNIC, you just configure a VNIC client. This shows a couple of components, a VNIC server and a logical port in the virtual I/O server. When you configure at the management console, the HMC, the VNIC client, you don't worry about those other ones. Those get instantiated under the covers. So just letting you know they're there for reference, and it kind of helps make sense when we talk some more about VNIC failover and we talk about backing devices. But just know that you really don't have to worry about configuring those individually. It's only the VNIC client you configure individually. So what you have here is that, I talked about this being a virtual adapter, this VNIC client being a virtual adapter, and you see that red line that flows over to the virtual I/O server. And that is really a control flow, which means that, it's giving information to the virtual I/O server on, where packets are to transmit and where buffers are to receive. But the actual data, the actual packets are flowing directly between partition memory and the adapters themselves. So there's no copy of the partition or of the packets in this case. It's all directly DMA from the partition to the adapter, as I said. If you're familiar with NPIV, this is that same technology we use for NPIV, where you have a virtual fiber channel adapter in the partition, and there's a server and physical adapter in the VIOS that actually moves the data. Device driver in there that actually is interfaced to, but the data itself goes between the partition and the adapter. So I'm going to talk about backing devices in a minute, but so think of this logical port with the virtual I/O server and what physical port on the adapter. You kind of think of those as that's the backing device. Now, when I talked about SR-IOV, I said that looked like a physical device. And as you probably know, physical devices in a partition make that partition so that's not LPM capable. This is why we developed this virtual interface that leverages SR-IOV. So now these partitions with VNIC clients leverage a lot of the SR-IOV capability, including this capacity value or minimum bandwidth capability. But now you have LPM and other advanced virtualizations like remote restart and those kinds of things. Partitions with a VNIC client are capable of those kinds of things. So when you go to do an LPM operation, it gets disconnected from that link through the hypervisor, and it gets moved. And the one thing I wanted to, I sort of mentioned that these components in the virtual I/O server are not something you have to worry about. Once that partition is moved off that source system, the HMC does clean up those components that were in the virtual I/O server. That's not something you manually have to worry about. So on the destination system, HMC will have created the logical port and VNIC server in the VIOS, and then when the partition lands on that destination system, they get whipped back up. So, that was one of the driving forces for VNIC. Leverage some of the SR-IOV capability, but also provide advanced virtualization like LPM. This is just a quick chart that compares virtual Ethernet and VNIC. As I mentioned, sort of the key differences are the data, the packet traffic is moved directly between partition memory and the adapter. In VNIC, you do have this. We use QoS. QoS is an overloaded term, but you'll see it as QoS or capacity or bandwidth. They kind of get interchanged, but has that capability where you can, differentiate capabilities from a VNIC client perspective, where it's sort of that blender model with SEA that all the clients end up going through the same physical adapter with the same priority. The other thing we did with VNIC is with the virtual Ethernet approach, it's really a single queue that's used to move packets between the virtual adapters. On VNIC, we have a multi-queue approach, so you can have distributed, interrupts across multiple processors and things like that for using different queues. Okay, let's spend a minute on VNIC failover. So VNIC failover is, you can think of it as being analogous to SEA failover from the standpoint it's sort of a server-side failover. In other words, I still create a single VNIC client in my partition. I don't have to have multiple VNIC clients when I'm using VNIC failover. It's a single. But now I can also configure multiple backing devices. Remember, those backing devices are the sort of that combination of a virtual server logical port and adapter physical port. You can have up to 6 different backing devices. Now, to be honest, I think most I've seen are 4, but you can do 6, up to 6. One is active and the others are inactive standby. So when you configure the backing devices, as I say, you specify a virtual I/O server that you want to be used for, and they can be different. Each backing device can have a unique virtual I/O server. Similarly, each backing device can have, a different adapter physical port, and you can specify a different capacity value for each one of these backing devices. So, if you've got limited, you want to have a backing device, a physical port, be the backing device for lots of different VNIC clients. You could do that and give them limited capacity, again, because this is the minimum, and if something would fail over to it, could have used more than its minimum if there were no other users of that port. And then you also specify something called a failover priority, and this is what the hypervisor uses to determine which is the most favored backing device to use initially, and then if that device becomes not operational, where do I fail over to? And so it uses the failover priority that's specified there. So that's really what you do for each one of the different backing devices. This gives a lot of flexibility, and one of the things you want to do is ensure that I minimize the number of things that have to fail over when there is a failure. So if a switch goes out, if a VIOS needs to go down for some reason, this gives you a way to kind of distribute those things to help manage how things are going to fail over where your actives are at. But one of the other things I want to point out is that it's actually the hypervisor that is doing the coordination of the which is the active backing device based off of, what are operational backing devices and what are the failover priorities. And so it's really a single point that's managing that, which I think is helpful from the standpoint is you don't end up with potentially two people thinking they're the active backing device at the same time. It becomes very clear because the routing, it changes when you go from one backing device to a different one. So I think that's a helpful part of this design. The other thing I want to point out is the backing device can be dynamically added and removed. So if for some reason, you have a backing device that, you really don't want in the configuration anymore, you can remove it. And, if you need another one, put it back in. The other thing that you can use that for is changing, as I mentioned, there's a capacity value or the bandwidth, minimum bandwidth that you can have on a per backing device basis. If for some reason I've decided I need to change that, I can dynamically remove a backing device and then add a different one in with a different capacity value. So I've got a chart here that kind of goes through an example of how this works. I'll go through this quickly. Folks may have seen this before, but this is an example. I've got 3 virtual I/O servers with each having one backing device to a different adapter. And again, the traffic is not flowing through the virtual I/O servers. The traffic is flowing directly from partitions to the adapters. If for some reason, and I should have mentioned this, but in this example, you got 3 virtual I/O servers. One of the nice things about when you do that kind of configuration is I can now take a virtual I/O server down for maintenance and still have a redundant configuration. And that's one of the reasons why we added 6 backing devices. If somebody's interested in doing something like this. So again, we took down the virtual I/O server, there was a failover done, and then picked the failover priority that was the next favored. In addition to monitoring the hypervisor or the virtual I/O servers, the hypervisor is monitoring the adapters and the link directly attached to the port on that adapter. So if your adapter goes down, again, that'll force a failover situation. The other thing I should have mentioned is that, we have this feature called auto priority failover. And what that says is if you have a backing device that was either not online, wasn't there, or it was not operational and it becomes operational and it has a more favored priority, if this auto priority failover is enabled, there will automatically be a failover to that device. The assumption is if you have this enabled and you want, you have a device that has a most favored failover priority, then you want to be running on that. Now this can be enabled or disabled. And because there are cases where you may want that and you may not. One last point that I want to make here is that, for some reason, you're using a device, a failover to the device, and you don't really want it to be the active device from the agency, you can initiate a failover, and that will disable the auto priority failover. I went through that kind of quick, and a lot of things kind of quick. I'll pause real quick to see if there's any questions.
Well, I'm trying to keep up with some questions, Chuck, but there's some that I'm just not sure of. So okay. We do have some questions in here. There were some questions. Let me back up. I'm just trying to see. There were some questions on the sharing, on whether it's a weighted share or and I know you went through the sharing and I was trying to answer questions, so I didn't quite catch everything that you said then. And one is things like Rocky supported with the VNIC.
So the sharing is it's based off of the capacity values. So, it's not really a weight per se, but your capacity is what that desired minimum is. Now, for excess, if the question is about any excess, how that gets distributed,
Yeah.
We've got two flavors of adapters, and it's actually slightly different. For our newer 2-port adapters, it's strictly a round robin. It's distributed equally amongst the various, logical ports that have demand for more than their minimum. In the older 4-port adapters, it is based off of that initial capacity setting.
Okay. Can you change that? Can you change that dynamically, the percentages?
No, you cannot. I'll go through some of that a little bit later, but no, those are things, and you really need to think about this ahead of time when you're doing configuration. For instance, you don't want, if you're not going to initially configure all the logical ports on a physical port, and you think you may want to come back later, then you want to make sure you leave some capacity, and then the max, the sum of those can equal 100%. So, you want to leave some percentage of that capacity that can be available for adding new logical ports in the future. And again, these are minimum values, so there's not a downside to leaving a gap, assuming you can satisfy your minimum requirements without having to consume that full 100%.
Okay. And I had a couple people ask about Rocky support with VNIC. Okay.
So I've got some charts in here on Rocky, and I'm going to feed myself along here just to make sure we get to it. If we are running out of time, I may jump to it just to make sure that we get it covered.
Okay, and I'll hit you up with one more before I let you get going here.
Okay.
The question is, can we trunk multiple VLANs using VNIC?
There's multiple places where the trunking can happen. I'll try and explain this, and hopefully it'll make sense. From a physical switch port perspective, absolutely you can have multiple VLANs running over that single switch port, which also means you can have multiple VLANs running over that adapter physical port. Now, this is where it gets into, was the question really on the physical port, or was the question really on a VNIC client logical port? And the answer there is as well. So there's two parts of this. Is you can have multiple VNIC clients on different partitions that have different VLANs. And you can define VLANs as either using a port VLAN ID, which you configure when you configure the logical port, or you can have VLAN devices that sit, on top of, that drive already tagged packets through that VLAN or through that VNIC device. So you can do either way. So each of the VNIC clients can have different VLANs, and on top of those VNIC clients, you can have multiple VLAN devices. So hopefully I covered the question.
Yep. Okay. And actually, given that you have this chart up, I'm going to ask you one more. Let's just say that your leftmost VIO server didn't have that logical port, so you had it just set up with the 2 VIO servers and the client there. Then you come along and you plug in another SR-IOV adapter, and you back it up with that logical port and the VNIC server. Can that dynamically be added to the client partition as a failover device?
Exactly. You can dynamically add backing devices to a VNIC client. So that is one thing that that's kind of nice, is that if you do bring up another VIOS or you get another adapter and you want to, either redistribute or you want to, just add more redundancy, you can do that.
All right.
And
so
do it
I'm going to let you
dynamically.
carry on now, Chuck, so we don't get tied down here. All right. So thanks you.
Okay. Yeah. Okay. So again, here's some more VNIC and VNIC failover requirements charts. Again, I'm going to just kind of blow through these, and you can see that what's there. Because I believe Joe's going to make the charts available. So if you have any questions about that, hopefully those will answer them. If not, let me know. I should have mentioned my email address is on the front of it. So, if you're going through here and do run into questions, don't hesitate to send me an email, and I'll try and do my best to address them. Okay, so I want to talk about something that is relatively new. We actually came out with a technology preview of this last November, but we officially GA'd it for production just this month. And it's something we call a hybrid network virtualization. And as I kind of talked about early on, when we looked at VNIC, we were looking for something more efficient, and that was really going from 10 gigabit, and beyond. What we've really seen, when you're looking at 100 gigabit, soon to be available 200 gigabit, and not far beyond that 400 gigabit Ethernet, that just requires a tremendous amount of overhead to be able to drive those kind of link bandwidths. And so to do it with a virtualized kind of environment like we have with VNIC and virtual Ethernet, it just requires a tremendous amount of overhead to do that. And so we have a scheme, we came up with this scheme we call hybrid network virtualization, where we leverage our SR-IOV logical ports and our current virtualization technology, along with some of our proven bridging, or no, I shouldn't say bridging, redundancy capabilities, and added some automation into the HMC to enable some of the advanced virtualization capabilities that we have with VNIC, but do it with an SR-IOV logical port. And I'll take you through an example of this just to show you how this works. But it's really taken some well-known established components that are there today, and in fact I know of companies that actually have done this and have manually created scripts, but we have integrated this now into our HMC capabilities so that it becomes more automated, and it's really intended to address these really high performance, high speed networks that are some of them here and some of them coming. So this is an example, an AIX example, and what happens here is when you go to create an SR-IOV logical port, you do that like you normally do, and you configure it for the partition. But now there's an additional option, and I'll show you what this looks like on the screen, to make this logical port migratable. And we'll go through the details of what that really means. But so you can select that option, and what that then does is it gives you the capability to, as well, configure a virtual device, either a VNIC or a virtual Ethernet virtual device, and you sort of tie those two together. And when the OS sees these two and know that they are part of a virtual, a hybrid network, it will create, and this for AIX, and it's different for IBMI and will be different for Linux. Currently, the support is only there for AIX and IBMI, but Linux is on the horizon. But for AIX, it will create a network interface backup device, a NIB device for you. So that happens in the partition. Now, that can only go so far. And once this is done, And the partition is activated with this, or, you dynamically added the logical port with this backup device. You'll then have to, manually go in and do things like assign an IP address to that, which you would normally have to do. So there are a few of those configuration kinds of things that you would manually do that aren't automated from the HMC. And it will vary depending upon, what OS you're using. For IBMI, this is we use VIPA as the active backup kind of environment. Linux will be more of a bonding, active backup bonding kind of environment. So once that gets established and you've completed the configuration, then now you're in a position where this partition is still LPM capable. And when the HMC goes to perform an LPM operation, what will happen is they'll go to the OS and they'll say, hey, we're going to dynamically remove this SR-IOV logical port. That'll cause a failover to the backup device, the virtual device. And that virtual device then is the active device, and the HMC can then dynamically remove the SR-IOV logical port. So now you're back to a virtual environment for your partition, and the HMC can then proceed to move the partition to another system. And as we talked about before, then for VNIC, the VNIC server and the logical port get cleaned up from the virtual server. Then when the partition lands on the destination system, there will have already been, if it was a VNIC, the VNIC server and VNIC device driver, or SR-IOV logic port created in the virtual I/O server. The HMC will then dynamically add back in an SR-IOV logical port. And once that happens, the OS will see that, and they will connect it back up into the NIB, and then force a failover so that SR-IOV logical port, that performance path, that low latency, low overhead performance path, now becomes the active path on the destination system again. So that's our hybrid network support. A couple things that are key both with VNIC, and I probably should have mentioned this previously, but it's true here too, is that when you configure an SR-IOV logical port and you put it into shared mode, you can also configure, when you configure an adapter and put it in shared mode, you can also configure the physical ports. And one of the things you can do on the physical ports is put a label and a sub-label. If you've ever looked at the physical port configuration options, you'll have seen that. If you put a label in there and the HMC is going to use that label when it looks for a port on a destination system, either for a VNIC backing device or for an SR-IOV logical port for a hybrid network. It's going to look for a label that matches on the destination system the label that was on the source system. So that's something you want to think about, that you want to think about how you want to label those so that from an LPM perspective, that works. Now, it only uses the label, it doesn't use the sub-label, but something to be aware of. So this is just a screenshot here to give you a view of how this actually works from a configuration perspective. This is an HMC screenshot, and what you'll see here is, I go through my normal configure a logical partition capability. I do that from the partitions, panel, and I do the add port. And, the top part of this is basically the same as it's always been, but what you will see under the advanced settings is a new checkbox called migratable. And if you check that checkbox, you'll see those things that show up right underneath there where it says configure a new backup device. And this is where you can, either pick, a VNIC adapter or a virtual Ethernet adapter. And it will give some default backup device information. It will pick a default for you, but you can also select where it's sort of in a bluish small text, you can say configure backup device. You select that, and then you can go ahead and actually do additional configuration and change some of the configuration. So that's how you configure a migratable logical port.
So Chuck, you showed the releases. Oh, here you're going to do it a different. Okay, so I was just going to ask if the requirements were different from just SR-IOV, but now you just put it up there. So thank you.
Yep. As I mentioned, last November we came out with a technology preview, which had one set of minimum requirements for the version that we just came out with in May, the production ready. These are the minimum requirements, both from a firmware and HMC perspective, as well as AIX and IDMI, and well as VIOS. Again, you won't see Linux there. Something we're looking at for the future. I will point out that there is a blog out there in the under PowerVM that has a lot more detail than what I went through here that might be useful. It's focused on the technology preview, and fortunately it's in developer works, which so we haven't had a chance to get it updated, but we'll get that done as soon as we have the opportunity to. Okay. So, we've got a lot of different capabilities here with SR-IOV as well as our traditional SEA capability. So this chart is really just give you a flavor, a comparison, a high-level comparison of the various virtualization technologies. And I'll just quickly kind of run through some, a thought process you might want to have as you're looking at these, trying to make a decision. I talked about initially SEA virtual Ethernet. If you're happy with that and it does what you need, that's a very, it's a fine, tried and true technology that's there. Like I mentioned at the beginning, something that you might want to look at if you're standing up new systems using SR-IOV logical ports as the physical device in that environment, so you can, change or add or, grow into an SR-IOV VNIC kind of environment or hybrid network kind of environment in the future. The straight SR-IOV, if you have no need for some of the advanced virtualization like LPM, that's a very low overhead, looks like a physical device. Capability makes a lot of sense. If you are going to be looking at very high-speed networks and you need LPM capability, then I say, you ought to think about hybrid networks. It's a new technology, so let me bring that out. So it needs some burn-in time, but something to think about for maybe in the future. VNIC is a very simple interface to configure, allows multiple backing devices. And from a client perspective, it's that single device. You don't have to do any redundancy configuration in the client partition. So just some things to think about to differentiate those. So quickly here, these are the adapters that we support SR-IOV, but let me just move on. This is probably the more interesting chart. Similar, it's got the list of adapters, but for Power9 servers, it also gives you a view of, which adapters are applicable in each of the various enclosures. The ones in parentheses, those are the external drawers. And you want to make sure that you are looking at slot locations. When you're doing that, there are some limitations when you do the drawers and some of the in the scale out models, there are different capabilities depending upon whether the PCI slot is behind a PCI switch or not. The 100 gig adapters, you know, they're only going to go in direct slots. They're not going to be able to go under a PCI switch and won't be able to go in the drawers at all. Anyway, I think this is kind of a handy chart if you're trying to figure out what adapters go where. This is just to give you a quick. I'm sorry, was there a question?
No, definitely a great chart, as was your one with all the different kinds and what they support. Excellent charts here.
Okay. And this one gives you the view of how many logical ports there are per physical port. You know, what you can see is that, you know, as we've added things like VNIC failover, where you can use a lot of different logical ports for backing devices, you know, we've increased those logical port capabilities per physical port. Things to keep in mind, though, when you do have a failover, particularly with VNIC failover, you want to minimize the number of devices that fail over for each kind of failure. So even though there are, you know, you don't really want to have 120 different, you know, logical ports failing over to another adapter on the same virtual I/O server at the same time. You know, your failover times would be longer than you would like. So you want to distribute them as best you can to minimize how many things fail over when there is a failure. Rocky support. How am I doing on time? I'll kind of go through this. So we did add Rocky support last year. A couple things, and hopefully this addresses your questions. You know, those on the previous charts where it showed the adapters, some of them will say they're Rocky capable, and others won't. It's basically the 2-port adapters are Rocky capable, and the 4 ports are not. When you configure Rocky, and I'll go through this, but when there's a certain configuration, if you want to use Rocky logical ports, you'll have to configure the physical port to enable Rocky logical ports. There's a very different, as you might guess, resource requirement. There are very different resource requirements for Rocky versus a normal NIC port. And so when we enable Rocky, we can't enable as many logical ports as they're Rocky logical ports. I think this was one of the questions. Rocky logical ports cannot be backing devices for V. You know, that maybe you know the question was more, can you run Rocky over VNIC? And the answer to that is no. VNIC is strictly for, you know, traditional network traffic. Rocky logical ports cannot be the backing device, the physical device for a shared Ethernet adapter. Again, those are for only the NIC logical ports. So right now, you know, if you use a Rocky logical port, you know, it looks like physical I/O, and so those partitions are not candidates for live partition mobility and some of the other advanced virtualization capabilities. Okay, so I'm going to quickly go through and show you how you would configure a Rocky logical port. And the first thing you have to do is actually modify the configuration of the physical port. And you can only do this when there are no logical ports configured on that physical port. So, you know, you're going to go from, you know, the schematic system configuration. You're going to select the hardware virtualized I/O. You're going to select the action and modify the physical port. And of course, you'll have to select the physical port you want to modify. Once you do that, what you'll see is this maximum SR-IOV logical port option. And currently what we have, and this is only applicable for these 2-port adapters, are 3 options with the newer firmware releases where Rocky is supported. We have what we call a fan-out option. And for the 100 gigabit ports, this is that, in that chart that showed all the logical port maximum, these are the fan-out option is those maximums. And so it's 60 Ethernet logical ports on a 100 gig adapter. But and then there is also there's also an option that we call more of a high performance option, and that is, in this particular case, you'll see the 8 Ethernet and 0 Rocky. If you really want high performance NIC, the assumption here is that you wouldn't want necessarily or need a lot of these. Then you would select that option, and these have the capability to run, the 100 gig speeds, where if you've got this large fan-out configuration, an individual logical port wouldn't be able to run the 100 gig speeds. Now, the option that's highlighted here is how you enable Rocky. So you would select this option that says 8 Ethernet and 8 Rocky logical ports. And so that's what you need to do to enable Rocky logical ports on a physical port. Once you've done that, now you can go to a partition and, from the HMC, from the partition view, you can select the hardware virtualized I/O like you see there on the left, and that will give you the option for SR-IOV, and you can do the add port. When you do that, then it will give you either, you can select Ethernet or Rocky. You select Rocky, and then you select, a physical port, and then you can configure it like you would any other SR-IOV logical port. With the exception is that you'll see in the advanced options, you don't have things like enable promiscuous mode and a few things like that. So that's how you enable Rocky logical ports. Here are the minimum requirements. Again, I won't run through this, but just so you know what they are from an OS and firmware and HMC perspective. And let me say one last thing. For a long time, the VNIC, the Linux VNIC support was really a technology preview. It is no longer the case. Both SUSE Linux and Red Hat Linux now have production level support for VNIC drivers for PowerVM. Wanted to make that note. And I think given the time, let me quickly stop, see if there's any questions on what I just went through.
Well, let's let you go ahead and get through the rest of your material, Chuck, so that we give James a chance. And it looks like you're getting closer to the end of what you got to cover. And then after James, we'll have to see what we have time for to get any questions.
Okay.
I'm trying to keep up with them, but there's some that I just don't know. So.
Okay. So I'm going to quickly talk about quality of service, and I think that's probably the last thing. I've touched on this a lot, so I won't spend a lot of time on it, but I do want to make sure it's clear, because I think it is an important feature that comes with the SR-IOV and VNIC support. A couple of key things is that it is, it really regulates the transmit bandwidth. We don't do anything to monitor or restrict receive bandwidth. It sort of, doesn't make sense to throw away a packet once you've already got it. So it really, controls the transmit bandwidth. I mentioned it's a minimum, and like I said, it's the If there's unallocated or unused, and by unallocated we mean, the total configuration of all of the logical ports is less than 100%, that is available, both the unallocated and unused, for other logical ports to use that may have more demand than what is currently, what their current capacity or minimum bandwidth is. This is just a real quick example, and I'm going to run through it, where I've got two logical ports. Currently, one is running with a 2% capacity. So its minimum is 2%. The second one currently isn't active, but it has a 98% capacity. And what happens when that 98% capacity logical port becomes active and trying to drive as much traffic as it can is that the 2% capacity logical port now is going to drop down, because that 98% now is consuming the traffic. But it still gets, some of its traffic. Then when the 98% becomes, stops driving traffic, no longer needs to drive its 90%, you'll see the 2% drop off. So I just wanted to give you some view of how that can be dynamically changing as logical ports come and go and their demand come and go. I think we covered a lot of this. Again, not dynamically changeable. For the 100 gigabit adapters, the default is 1%. The granularity is equal to the minimum. So 100 gig, you get 1% granularity, and the other adapters that have a default of 2%, you have 2% granularity. And I'm not going to go through this. It's in the chart, but one of the things to be aware of is that for these 4-port adapters, the capacity also does dictate VLAN filters that you get from the adapter. That only comes into play if you're using VLAN restrictions generally. I'm going to just skip through. There's just sort of, the key things you want to remember is that as you're trying to size your system and looking at usage of logical ports, you got to think about how many logical ports I need and what my capacities are going to need to be. And, that's how I need to sort of balance where I need to put my logical ports based off of the physical ports on adapters. One last point is that we did add a maximum capacity. It's only available through the CLI from the HMC, but there is one there. For some reason, you need a maximum capacity. You really want to cap off the bandwidth of what a logical port can do. And we've seen a couple cases where this has been important, where you may have some network infrastructure that can't handle you've done some coalescing of 1 gig ports onto a 10 gig ports, for instance, and as we've mentioned, that you have the capability to drive more than 1 gig, and sometimes the infrastructure hasn't always been able to handle that. So we've had cases where people have wanted to cap what a particular logical port can do, and that can be done. And this just talks about that capability. The CLI, HMC CLI commands are in here too. I think in the interest of time, I should maybe I should mention this, that for VNIC, and when you want to do LPM, you really need to be careful. There's some inconsistencies between the way the 4-port adapters work and the 2-port adapters, and you can see that if you look back at the tables that there's the newer 2-port are all sort of one family, and the older 4-port a different family. But if you're using port VLAN IDs, doing LPM between those two families of adapters can cause some issues. So you really want to avoid that. Similar, if you're using some of the MAC and VLAN restrictions, they can also have some incompatibility. So you want to be somewhat careful. It's best when you're doing LPM, and again, this is where those labels can help. It's best to go from the 2-port adapters to 2-port adapters and 4-port adapters, 4-port adapters, if you're using PBID or VLAN restrictions there and MAC restrictions. I won't go through all that. Last thing I'll say is that here's some references. There's a red paper out there. It's pretty old. It really just addresses SR-IOV, doesn't have a lot. But there are some FAQs out there, lots of information out there for both SR-IOV and VNIC. So I'd encourage you, if you've got questions, that's one place you could go look.
Okay.
And with that, I'll call it quits.
All right. So let's do this. Chuck, maybe while James is going through his stuff, you could take a look at the Q&A panel and maybe answer some of the things that I didn't get to. I'm going to go ahead and, James, I probably need to show your stuff, I think, right, still? What happened to James? Here we go. Yeah, okay. Now we got James back. James, are you there now? There you go. All right. Had to make you
Yeah, I was muted. I was trying to talk, but I was muted on your end. So let me.
Yeah. So you came back in and you weren't a panelist then. So I made you a presenter. You can try again, James, if you want.
Okay.
So otherwise I'll show your stuff. Okay.
Yeah, I should be able to do that now. There was a special.
Oh, there you go. All right,
So,
looking good. Okay, so guys, Chuck went through a bunch of stuff on SR-IOV and taught us a little bit about what it was. There is a migration from what maybe you're using today with VIO servers to using SR-IOV. It's not. I'll say there can be complications to it. Let's put it that way. So James is going to talk to us about migration, all right, from virtual Ethernet to SR-IOV. And James, like I said, is with the lab services, and so there's a lab services tool. So just want to preface this for everybody. So the tool is not something free you get from IBM. You get it with lab services, with this engagement with lab services, and James can talk a little bit about that. So I just want to make sure that everybody's aware of that, no surprises there. But if you have a larger, configuration or infrastructure, and you want to do this migration, this tool makes it super easy and more failure proof. So we'll let James talk about that. Go ahead, James.
Okay, thank you, Joe. So I do have some slides in here that are kind of duplicates of what we saw in some of Chuck's as far as how to create a VNIC through the HMC. And so some of these slides I may go through a little bit quickly in the interest of time. So the original chart deck essentially was just an overview of this tool. I added some content that would show what you would need to do if you wanted to manually convert from virtual Ethernet to SR-IOV. In particular, in this chart deck, it's mostly focused around VNIC, but certainly SR-IOV logical ports are supported as well. So again, in the interest of time, some of these are duplicates of what Chuck had, but Chuck has already explained what SR-IOV stands for. It's industry standard. We used to have multifunction cards, IVE, HEA, which was IBM proprietary. This is, industry standard that comes with these particular PCI Express feature code adapters. And Chuck explained what VNIC is and the fact that, you get multiple backing devices. So I'll go through some of these additional slides. I believe Chuck already showed the architecture here, essentially, that you get with the VNIC client. The piece that I like to stress with customers is when you add this VNIC client device, either through the HMC GUI or the CLI, that the VNIC server component and all of the plumbing, what I call infrastructure on the virtual IO server, gets created automatically for you. And so unless you know how to look for that device, you wouldn't even know it's there. So it's not like virtual fiber channel where you have to create a virtual fiber channel host adapter and then map it to a physical port. when you create the VNIC client device through the GUI, it asks you which adapter you want to go on, and this VNIC server device gets created automatically. That helps facilitate LPM. And then if you were to delete that VNIC client device, through the GUI, it would also clean up all the VIO side. So just be aware that this is really controlled from the client, and it's not like virtual fiber channel where you have to manually go in and map this to a port. So some of the considerations for moving to SR-IOV, whether that be logical ports or VNIC, as Chuck mentioned, Virtual Ethernet with SEA has been around for many years. It's been works for a lot of customers still, but for customers that need higher performance, in particular number of transactions per second or lower latency, SR-IOV has some pretty distinct advantages. So there are, certain feature codes. There's prereqs that Chuck has documented excellently on the SR-IOV FAQ. That is on the IBM website. If you just search for SR-IOV FAQ, you'll find Chuck's very lengthy FAQ that talks about the prereqs, the AIX versions, HMC versions, system firmware versions. So converting from SR-IOV traditional virtual Ethernet with SCA to SR-IOV, really kind of the perfect time to do that. And what I've done with my customers so far is part of a new Power 9 deployment. So the customer would order a new frame. You would get these SR-IOV capable adapters. Unfortunately, you cannot LPM between virtual Ethernet and SR-IOV. So the migration method that we've worked with a few customers now is to actually build a small SEA device. And Chuck mentioned that you could do that on an SR-IOV logical port in promiscuous mode, ideally give it 100% capacity. And then you would use that SEA device to migrate over the LPAR from either the P7 or the P8 frame to the P9. And then this tool that I'm going to mention would then convert that LPAR in place from virtual Ethernet to VNIC with no downtime. And we'll get into exactly how that works. So that's the typical method we've done with a few customers now. And as you get a new frame and get these SR-IOV capable adapters, if you're interested in doing the migration, that would be the perfect time to kind of plan that out. So some of the considerations, I'm just checking the time here. So it looks like I have about 10 minutes. I'll try to go through this a little bit quickly. But some of the considerations if you're going to do this conversion, you've got this virtual Ethernet device. It may be an EN0 device. You may have interface-specific tunables such as TCP send space and receive space that you set on the interface. So you would need to create, and I've got slides coming up that shows goes through this process. But essentially, you need to create a new VNIC device or SR-IOV logical device for each client partition, either through the GUI or the CLI. You'd need to migrate the old IP address or the IP address from the old to the new VNIC device. You'd need to manually move those tunables over as well. Manually remove all the old virtual Ethernet devices, and then make sure you update the client's partition profile. So it's not a ton of steps, but if you're doing this for 60, 80, 100 LPARs, it's very time consuming and it can be error prone. So I worked with a customer just a few weeks ago. We migrated about 80 partitions, and they say this would have taken them weeks or months to do without this tool that I'm going to mention coming up. So the next series of slides, again, in the interest of time, I'm not going to go through this in a lot of detail, but some of these are copied from Chuck's presentation that he just went through, but it shows what you would need to do to add a virtual NIC to the client LPAR, and this is doing it through the HMC GUI and not the CLI. So, you go under the virtual NICs panel within the client partition itself, you choose add a VNIC, you pick a port, then you can pick a capacity. You can pick, a hosting partition, and I think Chuck mentioned that's the VIO server that would host that VNIC server device that we saw on this slide here. So you would pick a VIO server to host this VNIC server device in this panel, and then the capacity, and Chuck mentioned the failover priority and how that works with VNIC backing devices. And so this is just showing we would go under advanced NIC settings, and this is where you would set your PVID if you want to do VLAN tagging. If you don't want to do VLAN tagging, you can notice in the bottom box here, port VLAN ID 0, but that would not pass the VLAN tag. But if you set a value in there, the actual card, the firmware on the adapter, and Chuck can correct me if I'm wrong there, but the actual firmware on the adapter will tag that packet and will hit the switch, with that tag in place. So that's all handled from the client side when you create the virtual NIC adapter, VNIC adapter. And, obviously, Chuck mentioned additional backing devices. Most of the customers I've worked with have either done 2 or 4. It depends on how many, the feature code of the adapter they ordered, how many logical ports per physical port that they had available, and what they had to work with, how many client LPARs they wanted to stack on these frames. So I've had some that have done 2 and some that did 4, and I know one customer did 6 backing devices just because they had a lot of adapters and they wanted the maximum redundancy available for every partition. So this is just to show, how you would then do, you would do add entry, and then you pick another port and go through the same settings, pick a capacity, pick a port label, pick a port which may have a port label on it, pick a capacity and the failover priority. And so this is just showing, walking through the GUI how you would do that. You would, basically make sure that auto priority failover, you can either enable that or disable that. Chuck mentioned that basically controls if a physical link fails, if the adapter fails and it fails over to the next device in the chain, if the primary device or the one with a lower priority but comes back online, it would automatically fail back, just like SEA failover today, where if you rebooted a VIO server, the function fails over to the second VIO server with the higher trunk priority, and then when the VIO server comes back, it automatically moves the function back. This is very similar. You can disable that such that if it fails to the next device, that it won't automatically fail back to the primary device. This is just showing, how you can list this out in the GUI. So you can see that this has a port label, a port sublabel. One thing I will mention here, and this is a chart that again that I copied from Chuck's presentation, and he mentions on the bottom left the device name. If you notice, it shows unavailable. Once you run Config Manager, at least at the AIX level, it will come and show you ENT0, ENT1, whatever the device name is. At the AIX level. So that won't get populated until you fully configured the device from the OS side. So this is just showing, hey, I've got a adapter EN0. This is my virtual Ethernet adapter. I've done some tunables, which are highlighted here. I've set RFC 1323. I've set TCP send space and receive space to the non-default values. So those are interface specific tunables that you would need to document and save off. And then, one of the really nice features with AIX, and this tool does work with Linux, Linux on Power, and I'll mention that later, but AIX has kind of a little known feature called ifconfig transfer that allows you to dynamically migrate an IP address from one interface to the other. So the tool that I'm going to talk about uses this facility in AIX to move the IP from, let's say, EN0, which is a virtual Ethernet adapter, to EN1, which would be your new VNIC device. So that's how that's accomplished in AIX. So post, and this again is if you were doing it manually, we've created an ENT1 VNIC device, and you'll notice RFC 1323, TCP send space and receive space, that those are all disabled. They're no longer enabled. So then you would have to manually go set those yourself. And it looks like I've got an overlay here, but this is just showing how that you would put those back in place. Then you're going to need to remove, the old ifconfig, the interface down, detach it, delete it. I will mention that if you do this manually, and this is enforced through the tool that I have, There are some ARP cache issues with AIX. I don't know if it's a hard code within AIX, but if you bring the original interface down, so you've migrated from EN0 to EN1, EN0 being your virtual Ethernet and EN1 being your new VNIC, if you bring the old interface down, if config it down detach, the new interface, the EN1, will stop working. You can fix that really easily by just doing a chdev on and changing the state to up, even though it's already up, and it'll start working again. But there are ARP cache timing issues in AIX that if you try to do that in less than 20 minutes after you've created the new device and done the ifconfig transfer, it will stop working. And I've tested that extensively all the way up to 18, 19 minutes, and in every case it failed. There is a tunable that I was made aware of called an AIX global tunable called ART-T-Kill-C that can affect this behavior. I don't know all the downstream effects of that tunable, and so I don't, in my tool, I don't use that, and until someone can kind of extensively test that and prove that that won't have other downstream effects, I don't rely on that feature. So that's a little known feature as well. But it wasn't 100% reliable in the testing that I did, at least, so I don't take advantage of that. I enforce a 20-minute wait time to remove the old adapter, but that's all automated through the script I'm going to talk about. So I'll just keep going through these. These are showing how to save everything in the profile. Make sure that if sync profile is turned on manually, you have to overwrite the existing profile. So, what are the other options? So you could automate this yourself, right? You could write a tool to do this all through the CLI. A lot of customers don't like to do that because then they have to support that. New enhancements come out like Chuck's hybrid networking that he talked about that then have to be integrated into the tool. So, or you could do all these manually. The customers I've worked with, again, one had about 80 partitions. We have another very large PowerVM customer that just bought 10 E980 frames, and they're converting to SR-IOV a few hundred partitions. So if you were going to do that all manually through the GUI or try to script that, that could be very time consuming and error prone. So that's where this SR-IOV migration tool comes into play. This is a new tool that Lab Services that I developed. So what that allows you to do is to dynamically add in a new SR-IOV VNIC adapter. In most of these examples, I'm talking about VNIC. Since you get backing devices with that, there's some additional redundancy. You can add an SR-IOV logical adapter as well, but for purposes of this discussion, dynamically add in a new SR-IOV VNIC adapter to a running client LPAR. It currently supports AIX versions 7.1 and 7.2. I could compile a version for version 6.1, but however, I don't believe there is a TL, at least I could find 6.1 that supports VNIC backing devices. So most customers would want that, right? You'd want some redundancy there. So if there is a need for a 6.1 version, with a single VNIC with no backing devices, that can certainly be done. It's just at this point supports AIX 7.1 and 7.2. Linux support is planned for a future release that's mostly ready to go, and that applies to Linux on Power, both SUSE and Red Hat RHEL, Red Hat Enterprise Linux on Power. They do not support natively this ifconfig transfer option, so I'll talk about how the live migrate piece works with that coming up. Chuck mentioned maximum capacity setting. If you want to do a hard cap for a partition and say, hey, I've given you a minimum of guaranteed of 20%, but I don't want to ever let you exceed 50%, that feature is not in the HMC GUI. Discussions I have with developers, that's not on the roadmap currently to add that to the GUI. It is available through the command line, and it's available through this tool that I've developed. So really the kind of the secret sauce here, or the really nice feature of this, is then you can then live migrate with this tool from the virtual Ethernet to the new VNIC with AIX, no disruption. In all the 60, 80 LPARs I did with the other customer, I think we say maybe one packet drop for one particular one, which was probably not related to the actual migration. So no disruption to the application. It's completely transparent. For Linux, I had that marked as disruptive, but the way that I coded it and the way I've tested it in the lab, I haven't noticed any packet drops or any disruption when you change from the old to the new interface. But since they don't have a native facility like AIX, that's guaranteed to do that, I would just be a little bit more careful in how you do that in a Linux on Power environment. And when I say Linux on Power, it's mostly for SAP HANA customers. There's been quite a bit of interest in a tool like this because a lot of those guys want to move to SR-IOV, according to the SAP HANA experts that work on our team and lab services. So that live migrate is optional. You could just use this tool to add in new VNICs and stop there. But by default, it's going to live migrate the old to the new. And then also optionally, you can remove all the existing virtual Ethernet adapter. So it will, if configure the interface down, update the ARP cache, remove all the adapters. It figures out the default profile for the client and then syncs all the this changes into the current profile such that if you shut this partition down and reactivate it, then you're going to come up with your new VNIC and all the old virtual Ethernet stuff will be removed. So this animation, I'll go here. It's just a PowerPoint animation showing, we've got a virtual Ethernet device. We added a new VNIC. We optionally migrate the IP address from the old to the new, and then we remove the old virtual Ethernet. So that is all accomplished through this tool that I've written. And before I go into the final slide that I have coming up here, again, this tool came out in February. I've since used it with 2 very large PowerVM customers. We've done a few hundred LPAR migrations with this with no outages, no downtime. I have a few other customers that I'll be working with pretty soon to do the same thing. So I'll go into the next slide. This is our asset flyer that describes, what the tool is, why you might need it, what's the customer set, who do you contact to get it. Joe had mentioned this is a lab services only offering. You can't go download this from the IBM website. It's not a chargeable asset, unlike some of our other assets. We deliver this as part of the engagement model. So however that works for you, whether that's power to cloud credits or tip credits or DCP funding, whatever the funding mechanism is, green dollars, however you choose to do this, it's typically done in a week, but ends up being 3 days, 3.5 days on site. That we would deliver the tool to you, train you on how to use it, give you the wiki, all the documentation, and it's extensively documented, and then help you migrate as many LPARs as you can, while we're there on site. And then we fully expect that we won't get through all of them, in a week's time. And so that we would leave the tool with you, and then you would continue to migrate in your environment. So the one customer that I worked with that moved around 80 LPARs, we did 20 or so during the week. We could have done more, but they just needed to get change records and concurrence from the business and the application owners to do that, even though it was dynamic and during the day. So they have since done that all on their own using this tool with no outages, no issues at all. So the duration here is listed 24 to 40 hours, but basically 3.5 days on site or remotely. All the ones I've done so far actually have been remote due to COVID, but it's certainly deliverable remotely. And we've had a couple of new enhancements come out with the tool based on customer feedback. So that's something that we're very interested in. When we deliver this tool to you guys, if there's new features, new functionality you'd like to see incorporated, that's something that we develop and then deliver, updates to you as that becomes available. So right now, I think the plan is to put this on a resource link, which is how we deliver our PowerVM provisioning toolkit, LPM automation tool, some of the other tools that Lab Services has, and that would allow you to get, updates automatically to the new tool with new, new code, new documentation, that sort of thing. So it's not licensable, not chargeable. Again, the tool is yours, but it would be delivered as part of a lab services engagement.
So James, you mentioned AIX Linux is coming, but I missed if there was IBMI support.
There is not IBMI support currently. I talked to some of the IBM Lab Services, IBMI guys about that. And this tool is written in Python, and there were some limitations around, it looked like compiling C modules, specifically for SSH support that I used SSH into the HMC. So we did a little bit of work with that and didn't get very far. So that was kind of put on the back burner. So in discussions with my management, they've said if we get a lot more interest in this for IBMI, that's something we could focus on. But right now, the first focus was AIX, and then Linux on Power for our HANA customers. But if there's enough demand for IBMI, that's something definitely that could be looked at. It's just in the discovery phase when I was working with them so far, there were some issues with getting an up-to-date Python version. The version that apparently comes with IBMI is around 10 years old. It's a very, very old Python version 2, and they weren't quite sure how to get that configured for version 3. So I think it's doable. It's just there would be some effort on my part at working with our IBMI Lab Services counterparts to port that over.
Okay, thanks. All right. So was that that's your last slide then, James?
That is.
Okay. So everyone, I know we ran a little bit over. Apologize for that. Just a lot of material. Actually, I think all great material. So certainly SR-IOV, great technology. I think it's a really good thing to use. And if you're really on VIOS today, this migration tool makes it lots easier to move. And so if you're interested in that, you can contact James. Or you can contact myself, or if you have another IBMer that you work with, I'm sure, or even a business partner, feel free to contact them and they can get hold of us to set up an engagement for this. And as James said, lots of ways to pay for that engagement: Power Rewards, tip money, green dollars, and they're actually Lab Services is very creative when it comes to finding ways to pay for their services. So great tool there and an engagement. So I want to, again, thanks everybody, and sorry we ran over. Hope you have a great month. One thing for June, we're going to be covering roadmaps. We're going to have the offering managers for AIX and IBMI. We're going to go over the AIX roadmap and the IBMI roadmap to update you on what's coming. And so stay tuned for that. June 25th will be the date, and we'll see it then. I'll be saving Q&A and chat, Chuck, so we'll go from there. Again, everyone, have a great month, and thanks so much. And James and Chuck, thank you very much for presenting this. It was really great material.
Oh, thank you.
Yeah, thank you. It was great to have the opportunity, Joe.
Good.